Hello everyone and welcome to my YouTube channel NN Fabian Chemistry. So today we are to continue with the part 2 of the lesson deriving chemical formula of a compound. So please, for consistency, I beg that you watch a part 1 first before watching the part 2. And before you continue, please make sure you subscribe to my YouTube channel and turn on the notification button so each time I upload a new video, you'll be the first to know. Now, let's get straight to the lesson for today. Like I said earlier, it is the part 2 of the lesson on deriving the chemical formula of the compound. And today we are to look at deriving chemical formula of compounds that involve polyatomic ions. So if we look at it here, we have a table of some common polyatomic ions. There are actually so many of them that have just represented some common polyatomic ions or some compound ions that we use quite often in chemistry. So take note, unlike in part 1 where we could easily derive the valency of an element by knowing its position on the periodic table, for these compound ions you have to memorize the formula of the ion and the valency as well, because it's not possible to derive it. So you have to memorize it the way it is. Okay. So here again, we're going to look at some of the rules we saw in part 1 of the lesson. So let's refresh our minds on the rules involved when writing the chemical formula of an organic or of a compound. So the first rule says, write the chemical symbol of the elements separately. Write the valency of each element underneath the symbol. Where possible, we should simplify the valencies. After simplifying, if it's possible, we interchange the valencies. And we write the valencies as subscripts in front of the symbol of each element. Now, this rule applies for the case of compound ions. For compound ions, represents the valency out of the parentheses. When the valency is 1, of course, we know it is not written in the formula of the compound. So let's get started with some examples. So we have some examples here that we want to do. The very first one is potassium nitrate. Potassium nitrate. So just like we know, we have to represent the symbol of the element. So let's get to the periodic table in case you've forgotten to get the chemical symbol for potassium. So this is potassium on the periodic table. So we see the symbol and the group. It is in group 1. So what would be the valency of potassium? Of course, it is going to be 1 because it is in group 1 of the periodic table. Remember, for elements that are in group 1 to group 4, the valency is the same as the group number, while for elements in group 5 to 8, the valency is equal to 8 minus the group number. Okay, so let's look at it for potassium. So we have to write the symbol of the element. That is it for potassium. Okay, now nitrate is a compound ion, so let's look at it here. So we have here the nitrate, and that is the formula. We're going to forget about the charge now. The charge gives us an idea of the valency. And take note, you should not be confused. The charge here is +1, but the valency is 1. Valency is neither positive nor negative. Remember, valency is an indication of the number of electrons which an atom or group of atoms would use in bonding. So take note, the charge on an ion could be positive or negative, but valency does not carry a charge. Okay, so the +1 here tells us that it has a valency of 1, just like we find it in the table. So for the nitrate ion, we have NO3. So this is it, NO3. Now potassium is in group 1, it has a valency of 1. The nitrate, looking at it from the table, has a valency of 1 as well. So we're going to interchange the valencies. That is it. So the formula, therefore, of potassium nitrate is we have, okay, remember we do not write one in the formula of the compound, NO3, and that is the formula of potassium nitrate. Now let's look at the second example, that is ammonium chloride. Ammonium chloride. So looking at it at the table here, we have ammonium, that is the formula, and the valency is 1, right? So ammonium, we forgot about the +1 charge. For ammonium, we have NH4, and chlorine or chloride is there representing chlorine, tells us that chlorine is present in the compound. So let's, in case you've forgotten, let's go to the periodic table to get the symbol and the group number of chlorine. So here we have our periodic table. So we see chlorine here. What group? Group 7, right? So what would be the valency for chlorine? 8 minus 7, that is 1. Okay, that's fine. So for chlorine, we have, now ammonium has a valency of 1, chlorine has a valency of 1. So we interchange the valencies. And what is the formula, therefore, of ammonium chloride? So formula, we have, so that is the chemical formula of ammonium chloride. Let's look at the last example before you try some by yourself. Last is iron 3 sulfate. Iron 3 sulfate. So let's go to the periodic table to get the chemical symbol of iron. So here is our periodic table. Here we have iron. This is it, the 26th element. So that is the chemical symbol for iron. Now, iron is neither in group 2, 3, 4, or 5. So what will be the valency for iron? Take note, iron is one of the elements that have more than one valency. So for such elements, the valency to be used is often indicated in parentheses. So if you look at it here, iron 3 chloride, it tells us that the valency for iron we to use in this case is 3. So let's go. We have Fe. So we have Fe for iron. And for sulfate, let's look at our table. This is the sulfate compound ion, SO4 2 minus. So the charge is -2 and the valency is 2. So in represent, let's have SO4. We forgot about the charge. So now we know the valency for iron has been given. So it is 3. And for the sulfate, the valency is 2, right? Now, is it possible to simplify? Nope, it isn't. So we're going to simply interchange the valencies. That is it. We interchange. So what is therefore the formula of iron 3 sulfate? So the formula is Fe2. Now, the 3 is coming to the sulfate compound ion. So we have to put it in parentheses. S O4, and we put the 3 outside, out of the parentheses. So that is the chemical formula of iron 3 sulfate. Okay. Now try these examples, pause the video, and make sure you try these examples and come back to the video just when you've tried. Okay. So we have 4 examples of 4 exercises for you to try: sodium hydroxide, calcium phosphate, lithium hydrogen carbonate, and ammonium carbonate. Good. Now that you've tried, let's find out if what you've done is correct. So we start with the very first one, sodium hydroxide. Let's bring down our table. Okay. So there we have our table. We have sodium hydroxide. So what are the elements? We have sodium and we have the hydroxide compound ion. So sodium, let's get to the periodic table. In case you've forgotten the chemical symbol for sodium. So this is it. Sodium is Na, and it is in group 1. So what will be the valency for sodium? It will be 1, of course. So let's get it. So for sodium hydroxide, we have this. Sodium hydroxide, we have it in the table. So this is the hydroxide compound ion, OH minus, and it has a valency of 1. So we have it here. So sodium has a valency of 1, hydroxide has a valency of 1. We interchange the valencies. So the formula is, so that is the chemical formula of sodium hydroxide. The next is calcium phosphate. Calcium phosphate. So let's get our periodic table. Here we have calcium in group 2 of the periodic table. So what will be the valency for calcium? Of course, 2. And let's get to the table for the phosphate compound ion, PO4 3 minus. So it has a charge of -3 and a valency of 3. So we have calcium, phosphate. So calcium has a valency of 2, phosphate has a valency of 3. So let's interchange because it's not possible to simplify. So the formula of calcium phosphate is we have Ca3, and the phosphate compound ion, we put it in brackets. So PO4, and the 2 is out. So that is calcium phosphate. Okay. Let's look at the next, lithium hydrogen carbonate. So this is lithium. Let's go to the periodic table. So here we have lithium in group 1 of the periodic table. Okay. So lithium is in group 1, it has a valency of 1. we have lithium, and for the hydrogen carbonate, let's get to our table. So we have hydrogen carbonate, also called bicarbonate. That is the formula and the valency. So let's represent it. We have, so valency 1. Lithium also has a valency of 1. Interchange the valencies and the formula for this. We have lithium hydrogen carbonate. The last is ammonium carbonate. Ammonium carbonate. So we know for ammonium already, it is NH4. Ammonium has a valency of 1. Let's look at the carbonate. So here we have the carbonate compound ion, and what is the valency? 2. So we have CO3 has a valency of 2. We forgot about the charge. So is it possible to simplify? Nope. So we interchange the valencies. So the formula, we have, we put it in parentheses, of course, and we put the 2 outside, and carbonate, CO3. Remember, 1 is not written in the formula of a compound. So that is the chemical formula of ammonium carbonate. So thanks so much for watching the video. Please make sure you leave your comment in the comment section below. And if you've not yet subscribed to my YouTube channel, please do well to subscribe and turn on the notification button so you'll be informed when I upload a new video. Thanks so much for watching and have a nice time.